Hydropneumatic accumulators use the principle of potential energy in the form of compressing and expanding nitrogen gas to allow hydraulic fluid to be stored or expended in various applications. The nitrogen gas that fills the accumulator before being connected to the hydraulic machine or equipment is set to a specified pressure. This is called the gas precharge pressure. But why is it important to have the correct nitrogen gas precharge pressure in an accumulator? The simple answer is to ensure the accumulator operates as intended and to prevent premature accumulator failure. But there's a little bit more to it than that. Here we'll discuss what can go wrong with a bladder type accumulator, but the same principles apply to other hydropneumatic accumulators. In order to understand how incorrect precharge pressure can cause premature accumulator failure, the minimum and maximum system operating pressures must be considered. Typical system pressures increases and decreases with actuation. If the accumulator precharge pressure is too close to the minimum permitted operating pressure, P1, the bladder will regularly strike the poppet on the fluid port, which will cause premature failure of either the poppet valve or the bladder. If the system pressure is too high in comparison to the precharge pressure, the bladder will be compressed, deformed and folded beyond its operational limits, which may result in premature failure. For this reason, the maximum permitted pressure P2 is determined in relation to the precharge pressure, and is not necessarily the maximum design pressure of the accumulator. It is therefore critical that the accumulator has the correct precharge for the machine or application in order to avoid premature failure.